All right, good afternoon, everyone, and welcome to this session, which is called How to Build Multi-Platform Maps with Google's APIs. My name is Fletcher. I'm a software engineer on the Google Maps API team based in Sydney.
Hi, I'm Enoch, and I'm a software engineer also in Sydney on the Google Maps API team.
So we thought we'd start out this afternoon with some reasons why you should be in this session as opposed to any of the other sessions that are currently going on. We know that Google I/O is an exciting time, and there's a lot of sessions vying for your time. So one good reason why you should be here is if you have a successful mapping application, perhaps on one platform. Let's say you have a successful Android application, and you'd like to bring it to other platforms. And you want to know how the principles that you should follow to make this as seamless as possible to do this cross-platform development.
Alternatively, you're starting from scratch. You're building a new application, and you want to target it for Android, iOS, and the web together.
What we're not going to do in this session is do any sort of deep dive into the code of any of the particular platforms. There was a great talk yesterday on iOS mapping using the new iOS SDK, and there's another session directly following this on Android and mapping that's going to go really deep into the code and so forth. So we thought we'd start out with a look at what the picture was 12 months ago if you wanted to do cross-platform mapping development. And the answer is that it was somewhat limited compared to what it is now. We had the JavaScript Maps API, which you can see on the left there. This was actually designed to work on mobile devices quite well, but it was only one application, and it didn't have a lot of the cool things that the newer SDKs do. We also had V1 of the map view, the Java map view for Android, which was also limited, it wasn't really well supported, and it was missing some of the modern features that are in the new ones.
Now, if you fast forward to today, we now have an SDK on iOS for you to write your maps on iPad and iPhone. Now we have version 2 of the Android Maps API, which is really beautiful. It has 3D graphics, tilt, or vector graphics, all that lovely stuff. And of course, the JavaScript Maps API is still going strong for all your web application needs.
So one of the things that we're going to be coming back to quite a lot in this talk is that everything is a balancing act. Now, this is particularly true when you're doing cross-platform development, because you're going to be looking a lot at trade-offs. You're going to be looking at when things should go in the front end, when they should go in the back end. You're going to have to deal a lot with UI things that may be trading off between different paradigms that you want to follow. So this is a common theme that we're going to come back to a number of times during the talk.
So this talk is in 4 parts. First of all, we're going to talk about some of the challenges that you might experience as you develop maps on 3 different platforms.
In the second part, we're going to talk about some good guiding principles for doing cross-platform development in mapping applications. And in the process of doing this, we hope to provide you with some solutions to the challenges of the first section.
Thirdly, we'll continue down the path of talking about some principles, and we're going to take a deep dive into backend infrastructure and how you can best structure your backend infrastructure so that writing apps on 3 different platforms is more efficient and more easy for you to do.
And in the fourth section, we're going to invite Jack Kwok, who's a software architect with Trulia, to come up and talk about Trulia's experience dealing with making mapping applications that run across multiple platforms.
So let's begin by looking at some of the challenges that you might experience as you develop mapping applications on multiple platforms. First of all, there's the question of effort. So clearly, if you have 3 different code bases targeting 3 different platforms, and each is written independently of each other, that's a lot more effort. And what is effort? Effort is time, and what is time? Time is money. So there's a question of, should I put more effort in and get a greater reward, potentially? But perhaps there's also greater risk there as well.
One of the next challenges with dealing with multiple platforms is dealing with the different use cases across different platforms. Obviously, people are going to use a desktop device differently to how they're going to use a mobile device. And there's also subtle differences in the way that particular platforms, even different mobile platforms, are used.
Next is the challenge of thinking about what are the capabilities of the platform that you're targeting. So each platform clearly has its own strengths and weaknesses. On the web, you typically have people at a desktop computer with a big screen real estate, lots of space for you to work with. But on a mobile device, less screen real estate. You have less space to work with. But there are unique capabilities that mobile offers, like GPS, storage on the device, cameras, all that kind of stuff. And as you remember from the keynote yesterday, Android now has great new location APIs, a great new geofencing API, and you can take advantage of these when you're writing an application for Android.
Yeah. The other thing to think about is the user experience. And when we talk about the user experience, we're talking about matching up with the way a user actually wants to interact with your application. This is particularly important when you're dealing with a mapping application because there are certain ways that people want to interact with a mapping application. There are certain things that they expect it to do, and there are certain ways that they want to use it. So ensuring that you have a good user experience is really quite important.
So let's now take a look at some of the principles that you might follow as you address some of these challenges, and we might provide some solutions that might apply to your situation as well. So to address the problem about effort versus risk versus reward, you need to work with your budget. You need to understand what are the business constraints for your particular organization. So every organization is going to be different. Perhaps your organization has more resources, more manpower, more time. In that case, maybe developing 3 separate applications is the right way to go, because you're going to end up with a really slick, beautiful experience on each particular platform. On the other hand, if you have limited resources, limited power, maybe you need to get to market really quickly, then maybe you just write it once. And here's an example of what you could do. Using the JavaScript Maps API, perhaps you just write the mapping application once. Obviously, it works beautifully in a web browser for desktop, but then you can also embed this JavaScript implementation into a web view so that you can put the same mapping implementation into a native Android application. Alternatively, you could just have your users navigate to mycompany.com and then build a beautiful website that works on mobile too.
But you'd say this is a balancing act, right? Because obviously there are advantages and disadvantages to both sides. So you need to make that decision. It is a balancing act. So the next point is recognizing the use cases. Now, I talked a little bit before about that there are different use cases. And really, the only thing you can do as a developer is to work out what they are, do some research, find out how your users are going to be using your application. Now, the key point here, perhaps, is the difference between a desktop application and a mobile application. Obviously, when someone's using a desktop application, they're in a different mode to when they're using a mobile application. If you're using a mobile application, you're often out and about, you're often doing something that requires an immediate answer, and you're doing something that needs to be more focused to the task at hand. When you're on a desktop device, you're perhaps doing more research, you're perhaps doing a more time-intensive and more full study of the task that you're trying to perform.
So as a great example of this, here's a screenshot from Expedia's website on desktop. And you can see they've taken advantage of the screen real estate afforded to them on desktop. For the hotels, there's great detail about each. There's the ratings, price, all the stuff in a tabular view that's great for research. But then if you focus your attention to the left panel, you see that there are many options to drill down and really focus your search. So that you can select on ratings, location, price. There's a little map there as well. So they're taking the screen real estate given to them and provided tools to the users such that it's really powerful for them when they're searching for hotels.
Now, conversely, this is some shots from Expedia's Android application, which is really great. And what they do here is that they really focus down the tasks that they're trying to deliver. So on the left, you can see this is their flight search page. And not only is it a lot more streamlined and a lot more clean than the desktop application, but it also takes advantage of the capabilities of the system. You can see here, it's automatically picked up Oakland and San Francisco airports as nearby airports and has put them to the top, so you don't have to type in an airport code to find flights from your local airports. On the right-hand side, you can see the hotel search page. And this is really quite different to the desktop experience. Here, everything is focused on the map. You can get things from your current location, and you can also do this filtering. But what they've done is they've really cut back their filtering options, and they've made it a lot more streamlined and a lot more focused than it was when you had all of those options when you have a desktop device.
So one other principle that you can take into heart is you need to focus on the correct UI paradigms for your particular platform. And what we mean by that is there's a balancing act between cross-platform consistency, that is between your various apps on the different platforms, and intra-platform consistency, that is between your app and other apps on the same platform. So as an example of this.
So it's a really good example of what we mean by cross-platform consistency. When we're talking about that, we want to make sure that our app feels like it's the same app, that it works the way it should across your different platforms. A great example of how you can do this really nicely is by using Google's mapping and web services. So obviously, if you have the same data across your different devices, then you're going to get the same results. If a user searches for a bunch of addresses on their desktop device, you can be confident that those addresses are going to be exactly the same on a mobile device. So the example we have here is some directions across the country. And you can see that they get rendered exactly the same way. They're exactly the same route between the desktop device and the mobile device. And because users are going to be switching between the two, having this kind of consistency across the platform is really quite important.
So by contrast, here's what we mean by intra-platform consistency. And a great example of this is to look at the back button on each particular platform. So on the left, here we have a screenshot from iOS. And typically, in an iPhone application, your back button goes in the top left corner. So if you're developing a mapping application for iOS, it makes sense to put it on the top left corner, this back button. On the other hand, on Android, the back button is typically provided by the operating system. There's a soft button on the bottom left corner. So you want to follow these UI paradigms for that particular platform so that your application feels as though it belongs in that particular ecosystem of apps.
Yeah, it's really quite awkward.
And there's nothing worse than opening up your Android phone and seeing apps that look like iOS on an Android phone. It's a little bit grating, isn't it?
Yeah, that's nothing worse than that.
Nothing worse than that.
Actually, I can think of a few things worse than that.
That's right.
But that's definitely in my top 10, I'd say. All right, now let's have a look at some of the back-end infrastructure that you can use to make some of the principles of the back-end infrastructure that can really make your development seamless between different platforms.
So one key aspect of strong back-end infrastructure is to have a shared data store. So it would be surprising and really weird if on a desktop you could search for restaurants, but then you get a different set of restaurants if you search on your mobile device. That would be weird. But that might seem obvious, but a more key point is that for user data, that needs to be persistent in the way that's cross-platform. So if a user is on your restaurant searching website and they save a list of locations, ideally he or she would be able to get that list of locations on their mobile device when they're out and about.
The next key point is that you should push functionality to the server side where it makes sense. If you're doing something that's common to all of your platforms, then it makes sense to push this logic to the server side. The advantage of this is that you only have to implement it once. You don't have to implement it multiple times for multiple different platforms. The other key thing that really helps it pushing server-side is if you're doing anything computationally intensive. If you're doing, say, some sort of analysis over a very large data set, then this might take a great deal of computing time. So it makes sense to leverage the back-end architecture that you have at your advantage rather than putting this to the device. The other thing is if you're doing a lot of computation on, say, a mobile device, you're going to really minimize the battery life. And that's going to annoy your users.
And then when you put all this data on the server side, where do you store it? You can store it in Google Maps engine.
Oh, yeah, that's a really, really good idea. So if you haven't actually had a play with Google Maps engine yet, you can sign up for an account at the Maps sandbox. We'll be there afterwards, and you can come talk to us and sign up for an account.
So if you have this strong backend infrastructure, how do you get your clients to talk to it? And a really key point is that you should use a shared communication format. So suppose today you're only targeting web. That's fine. But then if your website talks to your server using JSON, JavaScript object notation, then if you add another client, let's say you added an Android application, if that Android application spoke in the same format, JSON, then your server wouldn't need to be changed, because the server would then be agnostic as the client that is talking to it. And then you can add additional clients with less effort if all of these spoke in the same format. And other formats include XML, GeoJSON, which is a particular variant of JSON, which is great for geographic data.
So following on from that shared communication format, if you cleanly separate your front end from your back end, then you're going to have a lot less trouble with the actual development. A good guide is to put only things in the application which need to be in the application. They need to be application specific for that particular platform. Then you can push all of the rest of your the rest of your logic to your backend. The advantage of doing this is that it really makes you think about the interface that you're exposing to your clients. And once you have a nice, clean interface, it's really easy to add more clients in the future. So as Enoch said, your server can be agnostic about the clients that it's serving. The clients only need to know about the logic for their particular platform, and they need to know how to communicate with the server on the same interface.
So now one advantage of using Google Web Services is that there are so many of them. You can use geocoding, there's directions, there's distance matrix, places search, a whole slew of web services.
Slew. Elevation too. No one ever mentions elevation.
But there's a slew of web services.
Slew. Stop saying slew. Yes.
But, so what you can do with these web services is you can query them from the client side, but you can also query them from the server side as well. And here's an example of what you can do if you have strong backend infrastructure that leverages Google's web services. So let's say that you're querying Google's geocoding service, you're querying the places search service, great, and then you have some special source. You have some really interesting logic that combines these two pieces of information together. You can also combine some of your own data as well. And then your server can combine it in this interesting fashion that you've come up with, and then send the result back to the client. And by putting it into the server, you don't have to write it 3 times for each of the clients, right? And you also improve network latency because each of your clients, they won't need to talk to 3 separate backends and then combine it in the client.
So let's reiterate some of the principles we were talking about when we're talking about backend infrastructure. The first is to have this clean separation from your front end and your back end. So everything that needs to be in the front end should be in the front end, everything that needs to be in the back end should be in the back end, and you should have a clean interface between the two.
Your app should communicate in the same way so that your backends can be agnostic and you can add new clients easily.
And finally, you should push computationally intensive or common functionality to the server. You only have to implement it once, and you can leverage all of the power of your backends.
You know, in the end, everything is a balancing act. Your case is going to be special, and you need to think about how you're going to balance these things. As this turtle knows, he needs to think about, should he put more effort into the front end or the back end? I'd say the front end. Or he's going to put more effort in and then trade off.
Did you just come up with that front end and back end thing?
Maybe I did. Alternatively, he needs to think about, trade off between effort and risk and reward. I'm sure he wants to put more effort in so he doesn't crush that little poor guy down there. But everything is a balancing act.
And with that, we'd like to invite Jack Kwok from Trulia to come up on stage to discuss Trulia's experiences with doing multi-platform development.
Thank you.
Thank you, Jess.
Thanks.
Good afternoon, everyone. My name is Kwok. I'm the mobile architect at Trulia. At Trulia, we have built over a dozen native mobile applications along with our website to make it really easy for consumers to find the perfect home. Buying a house is a huge decision, and we have built some really great map-enhanced features to help. Home buying experience is inherently mobile. Today, we have applications across Android phone, tablets, iPhone, iPad, and more. Today, I'm going to share with you some of the techniques and principles that we have followed in building amazing map experience across different platforms. So at Trulia, we understand that a great user experience is key to an awesome app. And a responsive UI keeps our users engaged. I'll share a couple techniques later on how to really speed up the map interactions. Another principle that we have followed is we designed our backend API, web service API, to be completely device agnostic. So all our apps speak the same JSON format with our backend services. You really want to avoid the situation where you are returning specific custom data based on the device type. The reason is with a device-independent API, it really simplifies your maintenance and testing. And even if you're just creating for one platform today, once your app becomes successful, you want to be able to scale across different platforms really quickly. So let's see some examples. At Trulia, we give you the inside scoop on what it's like to live in a neighborhood. What you're looking at is our crime map. The red area indicates area of high crime. As you zoom in, more details emerges, just as you would expect. We have brought the crime map experience to the iPad and as well as on Android phones and tablets. Commuting sucks. Nobody wants to be stuck in a traffic jam. Our commute map is a visualization of commute times, driving times, as well as public transit times from any location. Users simply drag the marker and drop it at any location they want. And a dynamically generated heat map is generated on the fly and placed on top of Google Maps. We are bringing the same commute map experience to Android as well. One really cool feature about the Android SDK, Maps SDK, is the 3D functionalities. So all of the markers and your custom overlays automatically are transformed 3D with no additional work involved from the developer side, as the user tilt and rotate with gestures. So at Trulia, we have data over 100 million homes. Our data scientists use machine learning algorithms to create models and visualization of home values down to the block level. So how does all these heat map tiles work? A heat map is implemented in a tile overlay. And a tile overlay is a two-dimensional grid of tiles. On the right, you see that I've highlighted individual tiles with a red border. And each tile is a square image, a 256 pixel by 256 pixel image, uniquely identified by 3 numbers, a zoom level, an X position, and a Y position, like the URL you see at the bottom. So typically, our back-end service would process and normalize some external data, sometimes in XML format. And we would use Mapnik to generate the tiles in a device-agnostic way. In fact, all our devices and our website use the same set of tiles. So one thing to keep in mind is, even though you can add in the opacity in the browser with the JavaScript API, on Android, there's no efficient way to do that. So when you're generating your tiles, you probably want to bake in the opacity so that you can have one set of tiles working across all your devices and your website. So on Android, it's pretty simple to add a tile overlay. You simply extend the URL tile provider class to let the map SDK know where to fetch your custom tiles. If you want more customizability, like customizing the caching behavior, you can implement the tile provider interface yourself. And for iOS, if you have downloaded the latest version, which was released yesterday, there is new tile overlay capabilities that are very similar to Android. So I really like how Google Maps takes care of all the Mercator projection math for me. Like, it's so simple to add a tile overlay. It takes maybe 20 lines of code to add it into mobile. So the Google Maps SDK for Android and iOS actually share very similar abstractions like camera position, ground overlay, markers, polyline, polygons, etc. So if you're developing for both iOS and Android, you appreciate the consistency of working with similar classes across the platforms. One really key thing about making a great user experience with tiles is a robust caching strategy. At Trulia, we cache the tile images at 3 levels: at the tile server, at the content delivery network, and finally at the device local storage. So caching is especially important for tiles that don't update regularly. So for the prime tiles that I showed you earlier, they're only updated once a month. So there's no reason to refetch the tiles every time from your mobile device. It would just waste bandwidth. So at Trulia, we want to make search fun. We added draw search to the browser first. You click the upper right corner to enable draw search, and each mouse click on the browser, on the map, marks a vertex of the search polygon. And you double click to close the polygon, and within a couple of seconds, you get some results back. On the mobile, the experience is much more natural. You simply draw with your finger a path of the search area. So when we first built a prototype on iPad, we noticed it was taking really long time for the result to come back. So after some investigation, we find that the bottleneck was due to the large number of vertices collected in the search, in the path that user traced with the touch interface. So we come up with a solution by plugging in a polygon simplification algorithm, which is an algorithm that reduces the number of vertices while at the same time preserving the general shape of the polygon. So you think, since this is a mobile-specific issue, shouldn't this be implemented on the device side? Well, in fact, it's much more efficient if we push that into the backend. And there's a few benefits to that. First, you don't have to write a code, like Java code on Android and then port the same thing, writing Objective-C on iOS. And second, if we needed to tweak or optimize the geospatial algorithm, we just need to do it in the backend. There's no need to push an update to individual app stores. And finally, it saves users' battery life by not doing some complicated floating point operations on the device. So 3 key takeaways for today. Do all the intensive and shared functionality, push all of that into the backend. Design a platform agnostic API so that you can scale to multiple platforms quickly. And finally, design a robust caching strategy for a great map experience. I hope you have learned a few techniques today in building your own great map experience on multiple platforms. With that, I'd like to invite back Jess and Enoch back up on stage for a Q&A session. Thank you.
If you do have questions, please come to the microphones because it's being recorded. Yes?
Quick question about geofencing. Is that available on iOS and in the JavaScript implementations, or is it strictly Android?
So right now it's part of Google Play's services, which is only available on Android. I don't know of anything similar for things. iOS has something similar, it does not have it. Yes.
Right, but in addition, you could use the Tracks API, which has, you can analyze the data afterwards and do something similar as well if you have that.
And I guess the second thing is the geofence. Can you tie it to a polygon, or is it simply a point with a radius?
That's a good question. I actually don't know the answer to that. Okay. If you come talk to us afterwards, we can probably find someone who knows.
Great, thanks.
Hi, I enjoy maps, as you can tell. I'm actually curious about the new version of Google Maps that is now in testing stages. Is that going to have another version of Maps API that we'll be expecting to come down the pipeline?
So we did announce earlier, after the keynote, we've done a visual refresh of the JavaScript Maps API, so it looks similar to the visual experience you get with the new Google Maps.
Base tiles are similar.
Base tiles are similar.
Controls are refreshed, that kind of stuff.
Controls are refreshed, new markers, all of this sort of thing. Mm-hmm. In terms of other things, we don't actually have anything to announce at this time.
And would you expect that there's going to be something different? Because there's some new events that occur when you have some of the things with Google Maps that are new, such as the streets getting bolded up to a location that you've selected, or the slider events. Are those events that we might expect to see occur in our
We're really excited about what is coming up in the API in the future, but we don't have anything to announce right now.
Gotcha. Thanks.
Hi, everyone. I'm Homing, and I have a question for Jack. And I'm very impressed for the tile that you overlay on the different platforms. So I would like to know how do you generate those tiles, at different levels, because there would be a very heavy loading, say, if you have overlaid the Zoom for the whole San Francisco Bay Area, or just for the tiles, for the San Francisco downtown area, then the precision of the tile you generate would be different. So I would like to know how do you handle this kind of job in order to minimize the bandwidth or give better presentation on your applications.
So I'm not sure I understand the question correctly. Are you asking what it takes to generate the tiles with a lot of coverage?
Yeah, and the algorithm that you use on the back end.
Right. The algorithm is really specific to what heat map you are making. So for example, for a crime map, we have partners that provide us with crime data, crime reports, and those are in XML format. And the logic, the algorithm to how to make that into a colorful heat map, that's really something that is basically is really dependent on what the data is. So the crime map, generating a crime map is very different from generating a commute map or a home valuation map.
No, I put it in another way. For the precision of the maps, you overlay in generate the overlay tile. Say, for example, if you outline the whole the coastline of the United States in a 1 to 1,000 scale would be far different from 1 to 2 million. The scale would be different, and it would you need different precision, because at a very high level that you see the whole America, you do not need very precise coastline, because the user won't be able to tell the difference between 10 vertex or 1,000 vertex. So I'm asking in this aspect.
Right. So the tiles are images. They are not polygons. There's no vertices. So as you're zooming in, the tiles is identified by 3 numbers, x, y, and zoom. So when you're zooming, farther in, it's actually fetching a new set of tiles with a different zoom number with basically the right resolution, So the farther up you are, the tiles cover more area. When you're zooming way in, to the maximum level, that's a tile might be a block or less than a block. But when you're zooming all the way out, a tile is the whole Earth, the whole Earth. So that's basically how it works.
Okay, so thanks for your question. Yeah.
Any other questions? As always, there's a load of great information on the developer site for Google Maps.
And we'll be at the sandbox for the next 15 minutes or so as well. So come and chat to us there.
Thanks very much.